Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture for December 7th of 2025 is titled The Sun and Its Missing Colors. So what do we see here? Well, here we see a spectrum of the sun. Now, a spectrum is made when you take light from an object and put it through a prism or similar device, and that splits it up into the component colors of the rainbow. So we see everything from the very deep reds up here in the upper left to the deep bluish purple down in the lower right. And that shows all the different wavelengths of the light that are present in the sun just spread out. Now, a solid object, a hot individual object heated up, will give off what is called a continuous spectrum, where you see the entire spectrum of light with no breaks in it. However, when gases are involved, then we get spectral lines, such as those present here. Spectral lines are signatures of various elements where they absorb very specific wavelengths of light. So the atmosphere of the sun will then absorb the light produced in the interior and will absorb very specific wavelengths depending on the elements that are present. So we could use this then to identify the composition of the sun, at least to find out if an element is specifically there. If we can measure its wavelength here on Earth in the laboratory, we could then look for that wavelength in the sun, and that would tell us that element is present. Now, you wouldn't want to look at just one line. You'd actually want to look at a variety of lines and look for that pattern that the element produces. And when you can match up 5 or 6 lines, that gives you great confidence that you have correctly identified that element. Now, are all of these elements known? Well, the truth is we do not actually know what all of the lines are in the sun. In fact, there are some that have not yet been identified. Now, what is some of the problem with this? Well, certain elements will give off different lines depending on their states. So different ionization states where electrons are removed will change the pattern of lines. So carbon, for example, carbon can be neutral with all 6 of its electrons, and that will give one pattern of lines. If you take one of those electrons away, you get another set of lines. If you take 2 of them away, you get a completely different set of lines, and so on until you have removed that last electron. So the spectrum we see depends not only on the atoms that are present, but also on their ionizations. Now, could that mean that there are unknown elements present in the sun? And that would not be correct. The elements are all things that we know of because we've already determined all of the elements in the periodic table, so there can't be any missing elements in between them. There could only be very high mass elements, which would be very unlikely to be present in the sun. However, this has not always been the case, and in fact, back in 1868, when we were making earlier measurements of the solar spectrum, we actually discovered a new element there that had not been known on Earth at the time. So we found helium, which became named for the sun. Helium for Helios for the sun, as that's where it was discovered. And it wasn't until a decade or 2 later that we actually found helium here on Earth. So at that point, the noble gases such as helium were not known and were first found in the sun. So that was our picture of the day for December 7th of 2025. It was titled The Sun and Its Missing Colors. We'll be back again tomorrow for the next picture, previewed to be flying over Earth. So we'll see what that is about tomorrow. And until then, have a great day, everyone. And I will see you in class.